Hello everyone, I'm Nathal from MIDASoft, and today I'm going to introduce before you Midas GTS, which is the geotechnical internal analysis software of MIDASoft. This would be the contents of my webinar today. I'm going to talk about the overview of Midas GTS, where you can use Midas GTS for your projects. What kind of projects can Midas GTS handle? The different modeling features in Midas GTS, the different analysis features, and how do we keep up with the quality of Midas GTS. I'll tell you about the quality assurance and quality control and why Midas GTS can be a perfect product for all finite element analysis needs of your company. First of all, I would like to start by giving you an introduction about Midas and what we do. As you can see here, MIDASoft is a branch office of Midas IT, which is based in Seoul, and it is the headquarters for developing all our softwares. And you can see that we have various distributors and offices all through the world. We have opened a full-time office in New York about 10 years ago, and now let me show you the product line that Midas has. You can see that we provide software for geotechnical analysis. Midas GTS and SoilWorks are the two softwares that we market for geotechnical engineering. For bridge applications, we have Midas Civil and Midas FEA. For building, we have Midas Gen. And for mechanical engineering, we have Nestron FX and Midas FX Plus. Since we have softwares for all different kind of engineering, which requires computer-aided engineering software, we are the biggest CAE software developer in the world as of now. Now let me talk about the users of Midas GTS all across the globe. You can see that we have some big names like HNTB, Michael Baker, Atkins, Halcro, Bechtel, AECOM, Arup, Jacobs. So these companies are using our software for their geotechnical projects. Now let me talk about Midas GTS product overview, and I'm going to talk about the different application areas in which Midas GTS can be used. So as you can see here, Midas GTS is an all-in-one finite element analysis software dedicated to geotechnical engineering. Midas GTS provides a new paradigm for intuitive modeling, superb analysis capabilities, and speed and visualization of modeling and results in the same platform. We have combined the enhanced pre and post engine of Midas with a powerful and accurate solver from TNO Diana, and this combination is used to do almost all kind of analysis that a geotechnical engineer typically needs for their projects. Talking about the application areas of Midas GTS, Midas GTS can be used for deep foundation and soil structure interaction, deep excavation and temporary structures, unconventional tunnel intersections and tunnels, shield TBM analysis considering excavation process, vibration analysis for earthquake and blasting, underground structure, groundwater flow and coupled analysis, and finally you can also do slope stability analysis in Midas GTS for 2D and 3D projects. Now as we know that the topic for today's webinar is tunnel analysis and how Midas GTS can help for the tunneling projects. Let me first give you a brief idea about the tunnel analysis in Midas GTS. In Midas GTS you can model any tunnel cross section. You can model tunnel gallery and intersections. The gallery connecting two or more tunnels can be modeled. The construction staging of the tunnel can also be done. The tunnel passing through rock joint or fracture plane can also be modeled, and the foundation alongside a tunnel can also be considered for analysis. Now let us first talk about the straight tunnel and how Midas GTS can help you with the straight tunnel. For modeling the straight tunnel in any finite element analysis software, you need to model the cross section of the tunnel, then you have to create a solid for the tunnel, you have to create the outer ground. If you want to do construction stage analysis, define several construction stages so that you can create the whole model with different construction stages. But in Midas GTS, we have provided a tunnel wizard, and with the help of the tunnel wizard you can model any straight tunnel by defining the simple parameters. So let me take you to Midas GTS itself, and I'm going to show you how easy it is to model straight tunnels in Midas GTS using the tunnel wizard that we have. So this is the work window of Midas GTS, as you can see. So for modeling the straight tunnel, I'll straight away go to tunnel modeling wizard. I'm going to define the cross section of the tunnel, the shotcrete and rock bolt properties, the length and the number of shotcrete and rock bolts that I have, the excavation process. So I'm going to define the length of the tunnel. So let's say I'm doing the excavation in 10 different stages for 5-meter length of the tunnel, and in 5 different stages for the another 12-meter length of the tunnel. So the total length of the tunnel will be 110 meters. And for creating the finite element model, I'm telling the program that divide individual excavation into 5 different divisions. So here I'm providing the division as 5 at all the location. You can provide any division as you want. The divisions can be different for different uh, construction schedule. And once I define the excavation process, I can go ahead and define the mesh properties, the different stratas which are associated with the tunnel, and the results that I want to see. Once I click on OK, you will see that the tunnel model has been prepared by Midas GTS. And since this model has been created by the tunnel wizard of Midas GTS, you do not have to check it whether it is a correct model or not. Since it has been created using a wizard, it is a perfect model. It not only models the mesh, but it also defines a certain loading that we need in our project. It also defines the shotcrete. It also defines the construction stages that would be associated with this straight tunnel project. So let me go ahead and show you the different stages with this. So as you can see here, these are different stages. If I zoom in at this location, you can see how the excavation is going on for this straight tunnel. So this is very simple. If you are taking up the straight tunnel project, you just have to use the tunnel modeling wizard of Midas GTS to create a straight tunnel. And all the modeling, meshing, and load definition will be done by Midas GTS itself. Now let's talk about the creating of anchors. In Midas GTS, we have an anchor wizard that can be used to model the anchor automatically. And now let's talk about the complex tunnel system. Now as you can see on your screen, this is a very complex tunnel system which is done by one of our clients, and you can see how Midas GTS has been used to model this complex tunnel system. Let me go ahead and open this model in Midas GTS so that I can show it to you in a better manner. Okay, so I'm opening this model here, and this model will give you a very clear idea about how easy it is to model several complex projects in Midas GTS. Since it's a big model, it would take some time to open, but shouldn't take much time here. Okay, so the model is open as you can see here. Let me deactivate all the mesh sets and let me show you the solids only. So as you can see here, these are the solids in this model. Let me change the view type of the solid to shading. Okay, let me increase the transparency. So as you can see here, this is the tunnel system which has been modeled in Midas GTS. You can select some solids and increase or decrease the transparency level. And let me just select the outer solid here, and okay, so here I'm gonna increase the transparency of the outer solids and decrease the transparency of the inner solids. And here you can see the complex tunnel system inside this model. Since we have very simple modeling tools in Midas GTS, it is very easy to model this kind of complex modeling in Midas GTS. Similarly, if you want to see the mesh, you can just go ahead and activate the mesh, and this is how the mesh looks like. Talking about the tunnels and existing foundations, you can also model tunnel with existing foundations in Midas GTS. As you can see in this project, we have tunnel running below the foundation of buildings, and you can see the settlement or the deformation in the foundations because of the tunnel excavation. This is also one of the projects done by our clients. And you can also model tunnel intersection. As you can see here, this is a tunnel intersection model. You can see that there are several tunnels which are connected to the main tunnel, and it's very simple and easy to model this kind of profile in Midas GTS. If you want to do 2D analysis, you can go ahead and use 2D analysis tool of Midas GTS to do 2D analysis. So you can do 2D and 3D in the same module. You don't have to buy different models for doing 2D or 3D. When you open Midas GTS, it asks you whether you want to do 2D analysis or 3D analysis, and you can go ahead and select 2D or 3D to perform any kind of analysis. Now, first of all, let's talk about the element and material library in Midas GTS. As you can see here, in Midas GTS we have 16 material models, and you can select either one of them to perform analysis on your tunnel projects. Hook Brown, modified Moore column method, modified Cam Clay model, strain softening model, and if you want to use London Clay model, you can also use a London Clay model for performing analysis on your structure. But if you want to define your own material, you can use the user defined material and definition feature of Midas GTS, and you can use a user coded subroutine Fortran in Midas GTS. Now let us see the different modeling features that are available in Midas GTS that would lead to quick modeling of any tunnel project. So we have a variety of geometric modeling features that can be used to create the model very easily in Midas GTS. Before I show you the slides, I would like to go back to Midas GTS, and I'm going to show you some simple modeling features of Midas GTS. Okay, so I'll open a model that I have created for the sake of this webinar only, and it shows two curved tunnels, and I'm going to show you how easy it is to model this kind of project in Midas GTS. So as you can see here, we have two tunnels, and they are mirror images of each other, and we have a gallery connecting these two tunnels, and we will also model the construction stages for the left side of the tunnel by modeling the ground surrounding it. So for the sake of simplicity and to reduce the time that we are going to take for this webinar, I have only modeled the construction stages of the first tunnel. So let us see how easy it is to model this kind of a profile in Midas GTS. So first of all, I'll select the new model, and I will select the 3D analysis option. So the model type will be 3D, and first I'll create the cross section of the tunnel. For that, I'll go to curve, create on work plane, I'll create an arc. So I'm creating the tunnel cross section, and as you can see here, I have now created the tunnel cross section. But it is not complete yet. We have to connect the bottom nodes together. For that, I'll go to curve, create on work plane, and I'll again select the line, and this time I'll ask the program to snap between the two endpoints of the arc, and as you can see here, the edge has been created. So right now the cross section has been modeled using two different edges, but we want a single edge or a single wire to represent our tunnel cross section. For that, I'll go to make wire option in Midas GTS, and I'll select these two edges, and I'll click on apply, and now you can see that a single wire represents the tunnel cross section. Now I'll want to create the tunnel solid. For that, first I'll create a guide curve along the tunnel layout, and I will sweep this cross section to create a solid along the tunnel layout. So first I'll create a curve in 3D because the tunnel has vertical and horizontal curve. So I'm creating a 3D arc, So as you can see here, I have created a 3D arc for the layout of the tunnel. This is the top view of the model, and you can see that it has a horizontal curve. And let me show you the side view, which shows the vertical curve in the tunnel. To create the other tunnel, I will just use the mirror feature of Midas GTS, and I'm gonna define a mirror plane, and before I actually create a mirror, I need to define. Okay, so this is how the mirror looks like, and before I actually do it, I'll click on preview so that I can see whether I can create the perfect mirror or not. I'll click on OK, and you can see that now we have two different tunnel cross section and two different guidelines for creating the solids of the tunnel. Now I'll go to the generator feature of Midas GTS known as sweep, and I'll select the tunnel cross section for the first tunnel, the guide curve for the first tunnel, and I'll give it a name, tunnel 1. Before I actually create the sweep, I'm gonna see the preview. This is how it looks like. It looks perfect to me. I'll click on OK, and you can see that the tunnel solid has been created. Similarly, I'll create the second tunnel. I will select the tunnel cross section. I'll select the guide curve. I'll give it a name, tunnel 2, and I'll create the tunnel solid. So this is how we have created two different solids for the tunnel. And now I'm gonna create the gallery connecting them. For creating the gallery, first of all, I'll create the gallery at any arbitrary location. Then I'm gonna move it to the location where I want the gallery to be situated. For that, first I'll create a cross section of the tunnel. It's a circular cross section, and I'm gonna create it at any arbitrary location. Okay, so this is the location where I created the cross section of the tunnel, of the gallery, sorry. And now I'll create a gallery out of it. For that, I'll go to geometry. I'll create a gallery using the extrude feature of Midas GTS, and here I'm selecting the cross section, the direction, and I'm gonna extrude it by 150 meters. As of now, the length of the gallery doesn't make any sense because we will trim the length of the tunnel to make it a perfect length. So as you can see here, I created the solid for the gallery, and now I'll move the gallery at the specified location. For that, I can go to the transform feature and I'll move the gallery. So I selected the gallery solid, I selected the direction and the distance by which I want to move it, and before I actually move it, I'll see the preview. This is how it looks like. Looks perfect to me. And now I have created the gallery connecting the two tunnels. But as you can see here, there are certain duplicate areas between the tunnels which can be shown like this, and I will ask the program to delete the solid depending on the surfaces of the existing tunnels. So I'll go to geometry solid and I'll go to divide solid. I will select the solid to divide, which is the gallery solid, and the tool surfaces will be the surfaces of the tunnel that we have. And I'm gonna uncheck delete tools shape so that I can retain my tunnel. And once I click on OK, you can see that the gallery solid has been divided. So I'm gonna delete the undesired part of the solid that I do not need. And similarly, I'm gonna delete the undesired part of the solid at the other end of the tunnel. Okay, it looks like a little bit tricky to select, so I'm just gonna select it from the work tree and I deleted it. So this is how you can create gallery very simply in Midas GTS. Just create the gallery at any location and then connect the gallery using the simple tools of Midas GTS. Now the purpose of creating the second tunnel was to show you how gallery can be modeled. Now I'm gonna hide the gallery and the second tunnel, and I'm just gonna work with one of the tunnels so that I can show you other features of modeling in Midas GTS. So first I'll create the ground so that I can create the construction staging considering the existing ground. For that, first I'll create a rectangle face for the ground, and then I'll extrude the rectangle face to create the whole ground. So I'll go to geometry, curve, create on work plane, and I'll select a rectangle, and this is how I'm gonna create a rectangle for my ground. And I'm gonna generate the solid out of this face, and I'll extrude it by, let's say, 200. The length would be 200. I'll give it a name ground, and this is how I've created the ground for the tunnel surroundings. I'll increase the transparency so that I can see it. As of now, the tunnel and the ground share the same volume at the location of the tunnel. So what I'm gonna do is I'm gonna okay, let me first hide these undesired items that we have here. So I'll hide them. Okay, so for that I'm gonna use the Boolean operation so that I can cut the part of the tunnel which is common with the existing surrounding ground. So I'll use the Boolean operation as cut. I will select the Boolean master as the ground and the Boolean tool as the tunnel that I have, and I'm gonna select it using the works tree. And once I click on OK, you will see that now the tunnel has been cut from the ground. Also, I'm gonna delete the face that I earlier created for the creation of the ground, and you can see that now the ground and the tunnel do not share the common area. Now let's hide the ground for the time being, and let's play around with the tunnel. So first of all, we'll model the rock bolts on the tunnel. So I'm gonna create the rock bolts using several curve option in Midas GTS, and again I want to show you different features. So I am creating the rock bolts as you can see here, and if I zoom in at this location, you will realize that the rock bolts do not actually intersect the tunnel cross section, which is not good for us. So what I'll do, I will use one specific feature of Midas GTS known as extend 2D feature, and it can extend the existing edges so that they can intersect. So as you can see here, I am extending the existing edges to make it intersect at the cross section. So right now it looks perfect to me. All the rock bolts have been modeled, and now I'm gonna sweep translate these rock bolts at other location of the tunnel. So I selected all the rock bolts that I have modeled. I'll select the guide curve that I'll use to translate these rock bolts, and I'll define the location where I want the rock bolts along this guide curve. And before I actually do it, I'm gonna see the preview. Looks perfect, and I'll click on OK, and you can see that the rock bolts have been modeled. Okay, so now we have the rock bolts. Okay, so now you can see that we have the rock bolts. Now as I said before, I'm gonna model the construction staging for this tunnel. So what I'll do is I will cut this tunnel solid into several smaller solids depending on the excavation sequence. So first I'll create a surface at the cross section of the tunnel. So again, I'm gonna create a surface using the create curve option, and this is how the surface will be created. And now I'm gonna translate the surface at the location of several excavation stages of the tunnel. So I'm gonna sweep translate this rectangular shape along the guide curve which we used for the creating of the tunnel, and this is how they will be transformed. And once I click on OK, I have several rectangular shapes that I'll use to divide the solid depending on the excavation process. For dividing the solid, I'm gonna use the divide solid option. I will select the solids to divide, which is the tunnel in my case. The tool surfaces will be the rectangular surfaces that I have just created. So I'm gonna select the rectangular surfaces that I have here. Okay, so I selected all the rectangular surfaces, and now I'm gonna also divide the existing ground, because the ground has to be divided so that the meshing becomes perfect. And now once I click on OK, you will see that the tunnel has been divided at the locations where we want the excavation to be done. So as of now, you will see that we have individual tunnel cross sections. Let me delete the undesired part of the model here. So you can see that the same tunnel solid has been divided into several individual solids so that we can mesh them accordingly to create the construction stage model. So as of now, you have seen how easy it is to create a curved tunnel in Midas GTS and to play around with that tunnel so that we can create the construction stage model for the tunnel. Now let me go ahead and summarize these points using the presentation. So talking about the geometric modeling features in Midas GTS, the most complex thing to model in any geotechnical project is the modeling of the surface. For modeling the surface, we have provided a very special option in Midas GTS. You can define the vertex cloud. You can just punch in the coordinates of the several points of the surface, and Midas GTS will automatically create the surface for you. You can also use the trim and the divide features of Midas GTS, as I've already shown you. You can sweep a cross section along a guide curve. You can import the geometry from several standard for data exchange, such as step, initial graphics, exchange specification, and you can also export or import the neutral format file. For modeling the terrain, again in Midas GTS we have provided a very special terrain modeling tool known as Terrain Geometry Maker, and you can punch in the coordinates, or you can also import the digital map for the contours, and Midas GTS will create a terrain for you like this. So as you can see here, I imported the contour map. I created the surface at the location of a dam, and this is how I created the model in Midas GTS. Now let's talk about the mesh generation in Midas GTS. We have all sorts of measure which are provided in a standard finite element analysis tool. We have the loop measure, Delaunay measure, grid measure, tetra measure, and if you want to do structured meshing, you can use the map measure feature in Midas GTS. You can also play around with the meshing. You can see that you can convert 2D to 3D mesh. You can do the meshing at any location. In Midas GTS, we have an option of adaptive seeding. So at the location of the model where the stress change can be critical, Midas GTS will do finer modeling, and you can also define the meshing, the grading of the meshing, the size control depending on your judgment. You can extrude a 2D mesh to create a 3D mesh. So if you are analyzing any geotechnical project for 2D and you want to switch it to 3D, you can just extrude it to create the 3D model. You can also extract the shotcrete properties from the existing mesh that you have. Now let me take you to Midas GTS itself and let mesh the model that we are creating. So first of all, let's hide the undesired solids again. So I'll hide them. I'll hide this solid too. So let's start meshing. For meshing, I'll go to mesh, auto mesh, solid, and I will define the division, the element size, and I'm gonna select all the solids of the tunnel. I'll give it a name, tunnel, and I'll see how it would look like. I'll see a preview before I actually mesh it, and I'll click on OK, and you will see that the meshing has been done by Midas GTS. Now I'll mesh the outer solid, so I'm gonna activate the ground. I'll go to mesh, auto mesh, solid. I'll select the ground. I'll define the sizes, let's say 10, give it a name, ground, and this is how it would look like. I'll click on apply, and you will see that the meshing will be generated by Midas GTS. So you can see that at the location of the tunnel, finer meshing is being done for the ground, and as it goes outside towards the edges of the model, the meshing becomes coarser. So this is how simply you can create the meshes in Midas GTS, and you can also rename the meshes depending on your uh, wish. If you want to rename the mesh, you can rename it. So it's very simple and convenient to create a mesh in Midas GTS. Okay, so I was about to show you how to extract the mesh for the shotcrete. What you can do is you can ask the program to give you the surface meshes. So I'm gonna activate the tunnel solid that I have here. So I selected all the tunnels except the gallery that I have. I'll go to model, element, and I'm gonna extract an element from the face of the solid that we have. I'm gonna select the solids that we have here, and all the faces, as you can see, have been selected. And once I can give it an attribute, and I'll give it a name, let's say shotcrete. And once I click on OK, you will see that the shotcrete solid or the shotcrete has been extracted. Now let me quickly show you how you can extract the solid at one location of the at only the outer surface of the tunnel. For that, again, you can go to element and extract element from the face of the tunnel, and you can select the individual faces. So if you just select the faces, you will get the shotcrete only at the edges of the solid. So I'm gonna give it an attribute, let's say SC, and once you click OK, you can see that now we have the shotcrete, the 2D elements for the shotcrete, and we can assign them the concrete properties for performing analysis. So it's very simple and convenient in Midas GTS to extract the 2D mesh out of a 3D solid. Now after you do all the meshing in any finite element analysis software, you need to make sure that the mesh that you have generated, it's perfect or not. In Midas GTS, we have an option to check the mesh, and it can tell you whether the meshing that you have done for the project is correct or not. So as you can see in this model, it shows a free face inside the model which is not correct for the modeling. So it has to be get rid of. So you can check it before you analyze it. Talking about the modeling wizards, I have already shown you the tunnel modeling wizard and the anchor modeling wizard. In Midas GTS, we have a very simple construction stage definition dialog box. If you want to activate any data, just drag and drop it to the activated data field. If you want to deactivate it, just drag and drop it to the deactivated field. So for excavation, you can activate everything in the first stage and keep on deactivating it depending on the excavation stage. But if you are doing the excavation in, let's say, 100 stages, you don't have to go manually and define different stages. What you can do is you can use the construction stage wizard in Midas GTS, and it will define the stages for you automatically. Now let me show you what does it mean by automatic definition of stages. So here what I'm gonna do is I'm gonna activate all the mesh, and first of all I'm gonna show you how to manually define the construction stage in Midas GTS. For that, I'll go to define construction stage, or let's say I'll define stage 1 in which all the ground and all the tunnels are there. So I'll select all of them, and I'll save it. Now I'll select the first excavation stage and I'll excavate tunnel number 1. I'll click on save. To excavate, I'll excavate tunnel number 2. Sorry, I just have to save it before I. Okay, save. And now I'm gonna select new to excavate and I'm gonna excavate tunnel number 2. I'll save it, and now I'm gonna show you how the construction stage look like. So first stage, everything is there, and you can see that the excavation has been done in this model like this. But you have 15 different tunnel elements in this model, so you don't have to create individual excavation for individual tunnel parts. What you can do is you can use the construction stage wizard. So for using that, first of all, I'll delete the construction stages that I have already defined. So I'll delete all the construction stages, and I will rename the tunnel mesh set so that they look better. So I'll go to mesh, rename mesh, and I will select the mesh sets which are to be renamed according to a specified criteria. I have selected the mesh sets for the tunnel. I'll give them a name, tunnel. Okay, and I'm gonna first use the y coordinate to give them the suffix, then x, and then z, depending on the global axis. So once I click on OK, you will see that all the tunnel solids have been renamed. And let us see what do they represent. So the first tunnel solid represents the first excavation, the second represents second, third, fourth, and so on and so forth. Now I'll go to the construction stage definition wizard, and I'll activate the ground and the tunnel in the first stage because they should be there from the beginning. And then I'm gonna deactivate the tunnel mesh set starting from stage 1 till the last stage. Now once I click on OK, and if I show you the construction stages, you can see that automatically the excavation process is being followed for this tunnel. So the first stage, no excavation. Second stage, excavation for the first tunnel. Third, fourth, sixth, and so on and so forth. Let me just deactivate the ground solid and all other solids. I'll just keep the tunnel solids, and I'm gonna show you the construction stages. So first stage, the tunnel solids are there. Second stage, the first gone. Second, third, fourth. So it's very simple and automatic to define the construction staging in Midas GTS. Talking about the load conditions, in Midas GTS you can define the load on the surface, and it can be transferred to the finite element mesh automatically by the program, or you can directly define the load on the finite element. You can define a variety of loads as depicted here. The analysis types, in Midas GTS we have all sorts of analysis: static analysis considering the linear and nonlinear properties of the soil, the construction stage analysis, the seepage analysis, semi-coupled, consolidation, slope stability, response spectrum analysis, etc. And this is a graph which is animation which is generated by Midas GTS for the staged excavation of the tunnel with a gallery. Now talking about the different types of analysis apart from the tunnel analysis, we have excavation analysis where the real excavation schedule can be simulated. You can see the real excavation schedule. We can do foundation analysis for high-rise buildings. You can see the foundation analysis models generated by some of our clients. You can do seepage analysis considering the transient and static seepage, and these are the results for seepage analysis, the flow path. You can perform slope stability analysis for 2D and 3D using C-file reduction method or the stress analysis method, and you can also perform consolidation analysis. This is an example of consolidation analysis in Midas GTS. And talking about the dynamic analysis, you can perform response spectrum analysis and time history analysis. And in Midas GTS, we have already provided a database of 50 past earthquakes that you can select from for performing the dynamic analysis. This is an example of dynamic analysis on Midas GTS. Now let me show you the results for one of the tunnel projects that I have done with Midas GTS. So I'm gonna open the solved example so that I can show you the results. So in this model I have already analyzed the staged construction analysis of a tunnel, and I'm gonna show you how easy it is to obtain results from Midas GTS. Just go to the post stage, and let's say I want to see the displacements in different construction stages. So the first stage displacement will be 0. Move on to other stages and you can see the excavation is being performed and how you can obtain the results in Midas GTS. If you want to obtain the results at a specific location, go to the probe result feature and select the node where you want to obtain the result, and you can see that you can obtain the result at any location. If you want to go ahead and see inside the model what's going on inside the model, just go to the clipping plane and you can define the clipping plane at any location, and you can see the deformation inside the model. So virtually you can move inside the model and see what's going on in different construction stages. Now let's see how we can obtain the design forces for the shotcrete. For that I'm gonna activate the mesh for the shotcrete only. So here I'm gonna activate all the shotcrete mesh set. Okay, and you can see the 2D results for the shotcrete. So I'm gonna go to the 6th stage. I'll go to 2D element forces, and you can obtain the different forces for the shotcrete design. If you want to obtain the results for the rock bolts, just activate all the rock bolts mesh set, and you can go to the 1D element forces and you can obtain the 1D element forces for the design of the rock bolt. So this is how you can obtain results very easily from Midas GTS. Now let me summarize it using the presentation. First, talking about the system equation solver. We use a multi-frontal sparse Gaussian solver, and we have two iterative solvers, PCG and general minimal residual, and you can select any iteration scheme out of these four. This is a simple benchmark test that we have conducted for Midas GTS. You can see the different element types and the number of elements with several degree of freedoms, and you can see and compare the analysis time. Talking about the post processing again, you can see the different post processing results in Midas GTS. You can obtain several graphs, you can obtain the contour plot, you can obtain the tabular result. You can obtain the contour with or without meshing. You can obtain the ISO lines. You can obtain several animations from Midas GTS automatically from the program itself that would make your report look nice. And this is displacement contour with deformed shape, the ISO surface plots, the clipping plots on the curve diagrams. If you have a fault zone, you can create a curve on the fault and you can obtain the result on the curve. You can obtain the seepage flow path quantity. You can obtain the tabular result. You can create the graphs out of those, and you can obtain the 3D graphs automatically from Midas GTS, and you can plot the result versus the location and the stage at the same time. You can obtain the settlements. You can virtually move inside the model and obtain the results at several locations, and you can control the legends according to your own wish. Talking about the quality assurance and quality control, we have 5000 regression tests for Diana in test suite. And now let me talk about why Midas GTS can be beneficial for your projects. Why? Because it has a powerful pre and post processor. It has a user friendly interface that I've already shown you. We provide technical support on demand, on time. It has a reliable solver from Diana, and we have a user feedback development program that the development will be done based on the feedback provided by our users. So whatever type of analysis that they need, we develop it for them. It is time efficient, it generates quality reports, and hence increase the productivity of your firm. You can model complex 3D geometry in Midas GTS using very simple tools. You can see several examples here. You can use Midas GTS for modeling different piles and pile group behavior. You can do complex solid structure interaction. You can model tunnel intersections, conventional tunnels, unconventional tunnels can be modeled. You can model shield TBM tunnel. Staged excavation is supported in Midas GTS. You can consider groundwater flow. You can perform dynamic analysis. And we support 64-bit operating system, which makes Midas GTS analysis pretty quick. Talking about the software is one thing and how to use it is another. In Midas, we believe in providing training service to our clients. We provide it for free. So as you can see here, we have done several technical seminars all around the world in which we invite engineers from several places and they talk about their specific projects, and we also give a training about Midas GTS on this in these conferences. But for one-to-one training, we have a look office at New York City, and we are located at 45 Broadway. And whenever you need our help, we are one call away. We provide training, on-site and online training to our clients, and our response time is never more than 24 hours. So that was all I wanted to talk about Midas GTS today. I thank you all for listening to me for quite a long time here. And if you have any question, you can send your questions to the email that contains the link to this video. I thank you all. Have a good day.